Hi all, my name is Alessandra Jimenez. I am going to be helping you out today with BioChem I enzyme kinetics, and today we have a problem to solve for Km, okay? So the question today is, what is the Km for a Michaelis-Menten enzyme if the inverse substrate concentration intercept is -5 times 10 to the 5th inverse molar on a Lineweaver-Burke plot of its reaction kinetics? Okay, now this problem is actually very simple to solve mathematically, but before we do that, I'd like for you to understand what a Lineweaver-Burke plot is and how to use it, okay, to solve a problem like this one. So first, I want to give you the formula for Lineweaver-Burke, and it's pretty simple. It's 1 over V0 equals Km. Now, Km is actually the concentration of substrate where your reaction is at 1/2 Vmax. Now, you may ask, what is Vmax? And Vmax is actually the rate that your enzyme, like the fastest rate that your enzyme can go at excess concentration of substrate, okay? And times 1 over the inverse, 1 over substrate, right? Plus 1 over Vmax. Now, you may notice that this formula actually looks a lot like the line formula, and that's because it is. So you'll have y equals mx plus b, where b is your y-intercept, x is your independent variable, m is your slope, and y is your dependent variable. Now, with that in mind, we can certainly draw out Lineweaver-Burke so that you can understand what this means visually, okay? And what this means is that, okay, firstly, it's a line, right? And the slope of this line, m, equals Km over Vmax. Now, the x-axis in this plot is your inverse concentration, and the y-axis is actually your rate, right? Dependent on your inverse concentration. Now, this right here, this point right here, your y-intercept, will actually be very significant for other problems in the future, but for now, I want you to note that this one is 1 over Vmax, which is b, right? b in your formula over here, okay? Now, here, this value right here is the value that you were given earlier in the problem, right? So 1 over substrate concentration, intercept is -5 times 10 to the 5th inverse molar. So that makes this -5 times 10 to the 5th inverse molar. Now, that's great, but now your question may be, how do we get from here to getting Km? And I'd like to show you a way to isolate Km from your formula so that you can solve for this. And I'll also point out a relationship that is very important to note at the end of this algebraic manipulation, okay? So first, we're going to go 1 over V0 is 0 in any y-intercept, x-intercept problem. So your y should be 0, your y value should be 0, so 0 equals Km over Vmax times the concentration of the inverse concentration of your substrate times 1 over Vmax. So you have -1 over Vmax equals Km over Vmax over 1 over the substrate. And we're going to continue doing this algebra. Okay, and so we can eliminate Vmax on both sides, and you'll notice that we have -s over equals Km. Now, this is really significant, right? So you can definitely see that Km is equal to the value of the negative concentration of substrate. But before we try to solve this way, we should definitely note that our x-axis is given in inverse concentration. And if we actually make it resemble that, like make your formula here resemble that, you can actually see a very good relationship. So 1 is 1 over the substrate concentration, which matches, right, your x-axis, equals -1 over Km. So this, what you just solved for, was the x-intercept. So that means that your x-intercept is equal to -1 over Km. Now that we know that, this is where your mathematical easiness comes into play. -1 over Km equals the value that you were given earlier, right? The 1 over substrate concentration intercept value. And basically you cross multiply. And if all your math is correct, then you should end up with Km equal to 2.0 times 10 to the -6 molar. Anyway, I hope that this is very helpful for you. But before we go, I really want to point out the really significant parts of Lineweaver-Burk. One is that your y-intercept is 1 over Vmax, which you'll be using a lot in later problems. And the one specifically for this particular problem is that your x-intercept is -1 over Km. And this is true for any Lineweaver-Burk plot, okay? So if you can just remember that -1 over Km is the x-intercept, problems like this will be very easy to solve. But now, I hope that you use this basically to understand why -1 over Km is your x-intercept. Anyway, wishing you the best. Have a great day.